All right, good morning, everybody. We're going to look at 2.4, the valence electron review in the conductivity and ionic bonding unit. A couple things I want to think about with this. There are two images in this worksheet that didn't make it onto the worksheet that you're working on. So I'm going to show them in this video. Hopefully that will help you out with this. Yeah, I'm not going to necessarily give you all the answers for this, but I want to work through this a little bit and give you some good detail with it. All right. So, valence electron review. As you look through this, remember two main things I want you to remember from Bohr models before, that valence electrons are the outer level of electrons. So if I'm looking at this argon Bohr model here, it's only the ones on the outside are the valence electrons. So argon has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Even though it has 18 total electrons, it only has 8 valence electrons. The other thing is that the last group on the right side of the periodic table is the noble gases: helium, neon, argon, all of those. And they're called noble gases, and they are non-reactive because they have a full valence shell. So with that being said, let's move on a little bit. First off, next reminder, when we looked at the periodic table, we saw that things in the same column had the same number of valence electrons. So all of the ones in column 1 over here, those all have 1 valence electron. All of the ones in the next column here, they have 2. We skip this middle part. We're going to put a big red X through it because the transition metals, the lanthanides, the actinides, they don't behave the same way. I've talked a little bit about that with some of you, but don't worry about that. We're not worried about those ones right now. All right. Then we come over to this column. These all have 3 valence electrons. These all have 4 valence electrons. These all have 5 valence electrons. These all have 6. These all have 7. And these almost all have 8, except for helium. And remember, helium is a little bit weird because the first electron level only holds 2 electrons. So first valence electron shell holds 2 electrons, so it is full when it has 2, and that's why helium goes over here and not over here. Okay? So those are some important things to think about there. All right. We're looking at the periodic table, so I want you to use a periodic table and look and see, oh, nitrogen, oxygen, fluorine, argon, aluminum, potassium, magnesium. How many valence electrons do they have? So just to think about this again, nitrogen is in, we've got 1, 2, 3, 4, 5. So nitrogen would have 5 valence electrons. I'll let you work through the rest of those there. I will post this video after it. We're thinking about the octet rule. The main thing is that if they don't have 8 electrons or a full valence shell, then atoms are going to do one of 3 things to get to a full shell. They're either going to give up electrons, they're going to take electrons, or they are going to share electrons. This unit we're going to focus on giving and taking. That is ionic bonding. Next unit we'll talk about sharing, which is covalent bonding. All right, so here we are. We're thinking about lithium has 3 electrons. This is the diagram on the right that you didn't have. But a lot of you have seen a lithium Bohr model before. So what can lithium do to achieve a full valence shell? It could give up 1 electron, or it could gain 7 electrons. And I want you to think about which one of those is it most likely to do? Which one of those is going to require the least amount of energy? All right. And then we want to think about which ones would need to gain only 1 more electron to have a full valence shell. So what I want you to do for this next one is to go through this table, find the number of valence electrons using a periodic table just like we did before. Is it a metal or a non-metal? Think about that from our division that we looked at in the first part. Will this element steal or give electrons? I want you to think about that. And then how many electrons is it going to steal, or how many is it going to give up? Okay. So come on down a little further. Here is the other picture that was not in your worksheet. For those that you said would give up electrons, we want to think about what they're going to do and what they're going to look like afterwards. So if the outermost shell gives up all its electrons, then the next shell in becomes the outermost shell. So that makes it the valence shell if there are no electrons in the shell above it. So I want you to think about these differences between these two things. Then I want you to think about charge. Remember, we talked about this before. If you lose the negative electrons, you become positively charged. Remember, you can always go back and compare the number of protons and the number of electrons. If it has more protons, it's positive. If it has more electrons, it's negative. Protons don't really change. In this unit, we're talking only about electrons changing. So elements are either gaining or losing electrons. Their number of protons is not changing, because if their protons change, that changes the number of element or the type of element it is, and that is a nuclear reaction. And we are not talking about nuclear reactions in this unit. All right, so thinking of charge, explaining your answer. And then I want you to think about that. Oxygen, this one, oxygen gains 2 electrons, brings its valence shell up to 8, which is full. And I want you to think about maybe even coming up with a couple of ideas of atoms that would give up 2 electrons. Where would they be in the periodic table is my hint for you. With these ones, you're thinking about matching up. These ones are going to give up, these ones are going to steal. How are you going to match them up so the one that gives up, how many electrons it gives up is the same as the amount that these electrons over here are going to steal. So draw a line in between the 3 elements that match up. And then final thing, it doesn't just have to be a one-to-one atom thing. Oxygen needs 2 electrons in order to fill its valence shell. It can form a bond with lithium, an ionic bond with lithium. Lithium only gives up 1 electron, right? So I want you to think about how many lithiums you would need to match up with 1 oxygen. And if you draw kind of the Bohr models, that's a really useful way to do this. All right, that's all I've got for here. Good luck getting this done, and I'm going to move on and do another one.